We're going to try another related rates problem here. We've got the radius of a circle decreasing at a constant rate of 0.1 centimeters per second. In terms of the circumference C, I want the rate of change of the area of the circle in square centimeters per second. Remember, when you're doing these problems, anytime you have something mentioned that is a rate is a derivative. Okay, and I really encourage you to list your rates. So when they say the radius is decreasing, that is the rate of change of r. That's dr dt. And notice it's decreasing. You always want to watch your signs here. So it's negative 0.1. Okay. They want the rate of change of the area of the circle. So they're asking us for dA dt. Okay, and they're not giving us that. We're looking for that in centimeters per second. And they want it in terms of the circumference C. So I know that circumference is equal to 2 pi r, and I'm just going to leave that there for a second. But they're asking for the rate of change of the area of a circle, which is pi r squared. So if you notice, if you go back to the original rates, there's a dr dt mentioned, and there's a dA dt. They don't mention a dc dt. Okay, although they do mention circumference. So I'm thinking I need to take the derivative of the area equation first. Okay, that's going to be derivative of a with respect to t is equal to 2 pi r times the derivative of r with respect to t. Okay, now they want me to find the rate of change in terms of the circumference c. Okay, now we know a couple things here. We're looking for the rate of change of area, so we're looking for dA dt. So we got to fill in everything on the right side of the equation. We know that dr dt is negative 0.1. Okay, we have that. And so if you look at this, the circumference is equal to 2 pi r. They're the same thing. So I think all I need to do is make a substitution here into my equation. All right. 2 pi r is the same thing as the circumference. And that means that dA dt is going to be equal to negative 0.1 times c. And let's see if that's a choice. Yes, that is in fact a choice. That's option B. Okay, so I wasn't exactly sure where that was going. I thought maybe I was going to have to take the derivative of c with respect to t and do some kind of substitution in place of something else. But if they mention multiple equations, try to figure out which one you need to take your derivative of. And I knew in this case because they were talking about the rate of change of the area. And a lot of times, maybe you can solve for a variable and replace it, or maybe you have to find one value in one equation to substitute into the other equation. But even if they have multiple equations, these are still relatively doable problems if you just write everything down and you just keep moving methodically through the problem. They can potentially work out pretty nicely.